And welcome to the next talk. My video is flickering, so I'm going to be fast in my transition. Just to note that the auction for the Sector tickets is ending soon. And thank you, Matthew Marji, for your talk on subdomain takeovers. Take it away, please.
Thanks, Max. Hey, everyone. Thank you for taking the time to be here and to listen to my presentation. Today, I'm going to be speaking about subdomain takeovers. The goal here for all of us is to start at the foundations. So it doesn't matter your background in security or not in security. The goal here is this will be a guide for all of us to learn what subdomain takeovers are, how to exploit them, and really most importantly, how to prevent them. So why don't we jump in? Let's first start about who I am. Who I am is a bit of a dad joke. I work at Auth0, so Identity and Access Management, IAM. Okay, so that will be the first and last dad joke that I do today. My name is Matthew Marji. I am a product security engineer at Auth0. I am born and raised in Toronto, Canada. I am a big fan of espresso. The art and science around it is something that is definitely a hobby for me. I always like to kind of read two books, kind of one non-technical and one technical. So I'm currently reading Why We Sleep, definitely because I need to learn how to get proper sleep, and Secure by Design, which is a great book on architecting systems with security in mind from the beginning. In general, I really do love to share what I know and what I learn with others and empower others. And hopefully that's the goal today. So before we really get into the details of subdomain takeovers, I think it's really important for us to go over some of the details of DNS and the domain name servers and how that works. So first and foremost, what is DNS? So the acronym DNS stands for Domain Name Server. I'm sure you remember from back in the day, the book of yellow pages that we used to get. Essentially, the domain name server DNS is the yellow pages of the internet. What was the yellow pages for us mapped a business of some sort to a phone number. DNS is tasked with translating domain names to IP addresses. So as a very quick example, BSidesTO.ca is mapped to a number of IP addresses that your browser will go to load the page or to load the application. We will learn that DNS exists at different levels. So it's not as straightforward as we may think. Yellow Pages, for example, is just a book and it has a very quick translation. DNS works a little bit differently. DNS has a number of different levels. So if we take an example, which we will continue to see throughout this presentation, let's say we're looking for xyz.wordpress.com. Notice the dot at the end. The dot at the end is the root domain. Every domain that we want to resolve, and that's the term that we're going to be using, resolve, which is translating the domain to an IP. It starts at the root domain. The root domain will ask the next step. How do I get to .com? When I get to .com, which we can see is called a TLD or a top level domain, when we get there, we'll ask, how do we get to WordPress? And then so on and so forth. Let's dig in a little bit more. Let's make sure we have the terminology locked down. A recursive search means that we are going to request essentially a domain and go step by step down the chain of the different DNS levels until we find what we're looking for, the IP address, and work our way back. The recursive search is going to be handled by the DNS server that we have set, whether on our phone, on our router, etc. Cloudflare, for example, has a DNS. Google has a DNS. Our local ISP will have DNS. That is essentially the first step. That recursive search is handled by that DNS, and it will go through this hierarchy that we see here. So as we mentioned, the first step is always the root name server. And the root name servers know about all of the top level domains that exist. So again, the top level domains are those such as .com, .ca, etc. The second level domains are those such as what we said, Google, WordPress, etc. And then once we get to those ones, WordPress, Google, etc., they manage their own DNS records, which we will talk about in the near future, of the subdomains. So the subdomains, such as xyz.com, are managed and defined by essentially the second level domain. So WordPress, for example, manages where XYZ is located and what its IP address is. So once again, I really love to just make sure we really understand the concepts. So again, each level knows the next level in the hierarchy. Root name server up here knows about the TLD, and it's recursive because we work our way all the way down. And once we get the IP address that we're looking for, we work our way all the way back up to get to our original request and get the answer. So xyz.wordpress.com, we have our recursive name server. It goes to the root. The root asks, where is com? The TLD for com asks, where is WordPress? Whoever at WordPress manages DNS has a record for where XYZ maps to, its IP address. That is returned all the way up the chain and back to us. In a visual sense, again, on our local machine, phone, etc., we may have some sort of local cache if we've recently asked about this domain or subdomain. We'll quickly check to see if it's there. If it's not, we continue on again to our DNS server that we have set up. Again, Cloudflare, Google, OpenDNS, there are many options that we may have set. That will start at the root DNS server. It'll get a response back, go to .com, get a response back, go to WordPress, get a response back, and then it will know the IP address of XYZ. Now, let's get into a bit more of the meat and potatoes of DNS. So as we mentioned, with DNS, there are record types. So let's say, for example, we own WordPress.com. We will have to manage the DNS for that website. There are different DNS records that we can set up. One of them that will be the focus of this talk will be the Cname record type. The Cname very simply resolves one domain by looking up another. So this is referred to as an alias. So as an example, maybe xyz.wordpress.com is an alias for some sort of other domain. So once we see this, server10.wordpress.com, we will now have to, for example, go and resolve where this is located because we don't know the IP address of server 10. This is a very simple mapping. And what's great about Cname records are, we'll see in the near future, if we use Heroku or Azure or one of those websites where they have their own domain, we can essentially hide that by saying, well, if you go to xyz.wordpress.com, they don't really need to know that our application, for example, is at heroku.com. The next record, which is really important, is an A record. Very simply put, the A record is that translation that we talked about from the beginning. It's a translation of the domain to a IP address. Now, two other records that are important to note, but we won't mention too much in the rest of the talk, are the SOA record. This is the start of authority. So when we were going down our hierarchy of DNS to get from, let's say, the top level domain to the second level domain, we would need something called a start of authority. This tells us where do we go to get the definition of WordPress.com? Where is that hosted? And so on and so forth. So the start of authority and the NS records define the DNS name servers that we have, and it allows us to know where to go next. To visualize that a little bit more, let's take a look here. So imagine the .com DNS server. We expect when we are looking for WordPress.com, we need to know, where do we find this DNS server? Where is that located? That DNS server will have, again, a start of authority and a number of NS records, name server records, that says, oh, don't worry, you can find those servers at this particular location. So now there's a way for us to know once we get WordPress.com and where to go, we understand the mapping of how to find it. Now, let's get into subdomain takeover specifically. What if I told you that xyz.wordpress.com, that IP address that gets resolved, could be something that we could take over? Subdomain takeovers are possible when a domain owner has potentially misconfigured records in their DNS. There are a number of different subdomain takeover types. And in this talk today, we are going to be specifically focused on Cname records. So as you remember, we mentioned that if I have an application, let's say app.wordpress.com, and that is really an application that lives in Heroku, such as appcinnamon12.herokuapp.com. Well, what if I didn't want someone to know that my app is in Heroku? I want it to be an official WordPress.com subdomain that I manage. And really, it's just a Heroku application that loads. That's the perfect application for a Cname record. But what if the Heroku app no longer existed? And then what if I told you that Heroku allows for the reuse of app names? So appcinnamon12 could be reused again. And then what if I told you that we could manually on Heroku select that app name again after the application has been destroyed? Well, for the rest of this talk, we're going to focus on a particular exploit that I found, a subdomain takeover at Auth0. And this has to do with a domain that we had a CNAME for, slack-logger.it.auth0.com. And that was pointing to Heroku application that we had running. And very simply put, this was a website that employees could go to log in and set up Slack logging for their Heroku applications. What I really like to do is make sure that we have a step-by-step understanding or a checklist of how we know a subdomain can be taken over. So as we mentioned, for CNAME-based subdomain takeovers, they are possible when we have three elements in place. One, the DNS record for a CNAME is currently pointing to a non-existing application. Two, the provider at which this record is pointing to allows for the reassignment of that name, of that unique identifier. And then three, it's really about being able to find this gap and now creating an application with that same unique identifier name, and essentially, as we will soon see, be able to control what we see. But first, let's briefly discuss the known providers that allow this reuse of those identifiers. As you can see, Heroku, which is our focus, is a rather large part of the set of different providers that allow essentially unique identifiers to be used. WordPress, as we mentioned with XYZ, that is another example. And we see some other ones here. So this is what's really interesting here is Heroku is not the only provider or application, but there are many others that can be looked at. And so if you can think about automation, there are definitely ways to look for CNAMEs and see what the ending is, which will allow us to determine whether or not we should look further into whether this application exists or not. So going back to our real life example of the vulnerable subdomain that I found, let's take a look here. Again, we noted that the DNS record, this one, existed, but the Heroku application was removed. It was no longer being used. The real tricky part about subdomain takeovers and why they're so rampant is that there's nothing obvious that this application was removed, because the CNAME record in DNS is not necessarily removed once we delete the application in Heroku. That two-part process might be forgotten. You might have an engineer who deletes the application because it's no longer being used, or someone from finance because they realize that it's a stale application and is no longer necessary. But no one may remove the DNS record. And so now that's where the gap is. So the next question becomes, how do we know if the Heroku application exists? And if so, how do we even know if it's owned by us? Well, simply put, an application no longer exists, at least for Heroku, if you go to it and it returns a screen that looks like this, where it says there's nothing here yet. If you were to do a request directly to the application, you would receive a non-200 response. If we wanted to automate this by going through all of our Cname records for Heroku and any other of those providers that we listed, you could technically do that as a way to determine whether or not it's worth looking into a little bit more. But again, the difficulty is that if the application did exist, we may not necessarily even know if we own it or if it's been taken over by someone else. And that's the real scary part about subdomain takeovers. Because you have applications that live in Heroku that can be reused, but you have your DNS that is simply just a pointer to Heroku, you have a little bit of a struggle. You really need to check both Heroku and your DNS to make sure that the application exists and the record exists, or the application doesn't exist and the record is removed and no longer exists. So let's get into the nitty-gritty and do the takeover. So very simply put, I created an Heroku account. I moved forward and created a new application. And in Heroku, I just said, hey, I am very interested in taking Auth0-Slack-Logger. I'd like that app name, please. And they said, yeah, no problem. And therefore, I'll take that and create an application on my behalf. Now that we own the app, we will see here in our Heroku dashboard for that application that the app that I own now can be accessed at auth0-slack-logger.herokuapp.com. And when we go back to the Cname record that Auth0 is currently managing and has set up, well, slack-logger.it.auth0.com just simply points to what is now my application. So what's great is I've essentially now taken over this app, and at Auth0, whether they notice it or not, and most likely, as we mentioned before, they won't notice, I've now have control over what will show up as an auth0.com subdomain. Now, what we need to remember from what we learned from DNS is when we go to auth0-slack-logger, this is now a domain that needs to be resolved to an IP address. So now that I've created this application, we will still need to take a little bit of time for Heroku app to create all of the necessary records such that it resolves to my application. Let's take a look at that a little bit more. If I check /logger.it.auth0.com, as we mentioned, there is a Cname record. But now what we do is we wait because now Heroku is now defining the ways that you can actually go to my application. So while Heroku is doing that and getting that set up and making sure that this is deployed to the public for DNS to be able to pick up, we're ready to deploy something. So I just thought for the sake of simplicity, what I would do is deploy a simple PHP app. And all I did was create an HTML default page that would load, and it would just say subdomain taken over. And I deployed it, and lo and behold, that was the case. At slack-logger.it.auth0.com, I now was able to take over and manage whatever showed up here. So there we go. We saw an example, very straightforward, of how we could take over using Cname type subdomain takeovers on providers that allow for the reuse of applications. The way that I just deployed a simple page is very, very straightforward. But let's think about the type of damage that can be done using subdomain takeovers. One, you have general brand damage. What if I went to social media, Twitter, etc., and just showed my ponage of Auth0 and being able to take over one of their subdomains? What if I managed to use that as a phishing campaign? I mean, I do control an auth0.com subdomain now. And so there are definitely ways to get creative. I could create a replica Auth0 login page, request details for logging in and signing up that I can now store. And I could even take this a step further. If I wanted to understand what Slack logger was doing, I might be able to listen in to attempt to find services that may still be relying on this subdomain. And this could lead to further potential attacks. What's really interesting here is that these subdomain takeovers are vulnerabilities that are rewarded via bug bounty. And these subdomain takeovers have been found and continue to be found across a large number of websites. Apple, Microsoft, Starbucks are some examples on HackerOne that have paid out closer to the $5,000 range for subdomain takeovers on very important domains, or they've led to further attacks where services rely on that subdomain still, and there are ways for attackers to continue to do other steps and other attacks. Now, last but not least, the really important part here is, how do we prevent this? At the end of the day, there's no magic tool for prevention. It's really about having a process in place for reviewing, adding, and removing DNS entries. As we said, we want to make sure that when an application is removed in Heroku, that any matching record in our DNS is also removed. So things to ask for your organization, or even for any DNS that you manage, whether it be for your website, are you reviewing your entries regularly? Again, when you remove an application on a provider, are you checking your DNS entry? Do you check dig, as we saw in one of the screenshots previous, to see what DNS is returned, to make sure that it's no longer pointing to Heroku or that third-party application? And also, what we mentioned from before, you could create a tool that scanned your Cname records and went to them and determined whether or not they return a 200 response or not. And if they didn't, that could be an alert for you to look into further. So I hope this was a great opportunity for you to get a little bit of an insight into subdomain takeovers and hopefully demystifying it. Subdomain takeovers are very easy to find, relatively easy to exploit, and very easy with some process to prevent. The Cname record, as I mentioned, is one type of subdomain takeover. There is another type called a name server takeover, which I will be sure to share the details in our Discord channel if you're interested in learning a little bit more. But at the end of the day, I hope that you were able to take away how to detect, exploit, and prevent Cname subdomain takeovers. Thank you all for your time. Take care.
Awesome. Thank you very much for the talk.
Thanks, Mike. Thanks.
Doesn't look like we have any questions just yet.
Okay.
So if you want to hop on over, there's people talking about responses there, their favorite response type, I guess.
Awesome.
Yeah, I'll let you hop over there.
Perfect.
Thanks again.
I will hop on there.